Hey there, Mr. Myesis here, and I'm going to be talking to you about definite integrals and using just kind of the first we'll talk about really quickly what definite integral is, and then I'm going to talk about the fundamental theorem of calculus. So yes, it's fundamental, so it is an important theorem, but you know it's really fancy words for doing a definite integral by hand without a calculator. Okay, so what I have on the screen right now is some problems from our text here. And let's see if I can scroll down here. So basically the idea here is that the definite integral is the signed area here. I talked about that in the last video. So if I'm just looking at the idea of signed area, then I'm looking at, in this case, I'm just going to be looking at a 2x minus 1 goes like this. All right, and I'm only looking at the signed area between 0, sorry, that's 2x minus 1 without the absolute value. So the absolute value is going to go like this, with like a little check mark, right? And we're looking at this area here and the area right here from 0 to 3. So you know those are just two little triangles. So we would just find the area of these two triangles and add them together. So when we do that, we're going to get 13 halves when we add up the two areas. So that's what I mean by a definite integral. Now, not always is it a line to where we can find the area. We have a curve in this case, and we need to do some work to find the area under that curve. Now, I'm going to just go ahead and set up my definite integral here. So we're talking about the integral from 0 to 2 of 2x squared minus 3x plus 2 dx. So that's how we would set up our integral, our definite integral for the area under that curve. I'm going to go and let you do number 7 on your own. This is kind of a discovery lesson here, so I want you to kind of think about the signed area underneath the curve of, in this case, f prime of x, and then figure out what that would be if we did the antiderivative of that. Just thinking about signed area, all right? Okay, and then we'll look at the next few here, and also I'd like you to do number 8 on your own too. And number 9, so 8 and 9 I think you can do, just understanding the idea, sorry I guess I'm in my eye today, of signed area. Again, we're talking about signed area. Okay, so pause it right now while you do that, and then come back, and then I'll go over the fundamental theorem of calculus with you. Okay, so the fundamental theorem of calculus basically states that if you have a definite integral, you're going to do the antiderivative. All right, so you're going to do the antiderivative, and you're going to evaluate it from a to b by plugging in b and subtracting it from when you plug in A. That's pretty much all there is to it, okay? So let's take a look at some examples here using the fundamental theorem of calculus. I'm going to move my pad here so I can easily write a little easier. You might not see my face here, or I might come really close. Okay, so here we go. We're going to do the antiderivative of this. So this is 2y to the 1/2 plus 1. And we'll do the antiderivative. Why don't I zoom in here so you guys can see it a little better. And then we're going to get, so we're going to get here, we're going to get 4/3 y to the 3/2 plus y. And usually I put a line here to say I'm going to evaluate it from 0 to 4. And when I do that, I'm going to plug 4 in here after I've done the antiderivative. So 4/3, 4 to the 3/2 plus 4 minus, and then I'm going to plug 0 in, which is just going to give me 0, right? Okay, and we can leave our answer like that because that's an answer, okay? So we don't need to calculate that all out. Again, you don't need to simplify here in BC Calculus. All right, so we're going to do the antiderivative here. Now, this is a reverse chain rule, right? So I need a 4 to be a hook here. And if I do a 4, I need a 1/4 here. So then I'm going to get 1/4 times 1/6. 4t plus 1 raised to the 6 because I'm adding 1, divide by 6, and we're evaluating that from 0 to 1. So again, I'm going to plug in my 1 here first. So I'm going to have 1/24 times 5 to the 6th power minus, plug in 0. That's just 0. Well, hold on. That's not 0 because I'm going to have 1, right? So I'm going to have 1/24 times 0, 1 to the 6th. All right, so there we go. That's good enough as an answer. Let's go on to the next one. Whoa, where's it going? Where am I going? What's going on here? Now this one's a use substitution here, right? Because I've got a 2x minus 1 in a square root here. So I'm going to do some use substitution. So let me get some more room here so we can see what I'm doing. I'm going to go ahead and let u be equal to 2x minus 1. I'm going to go ahead and solve for solve for x. And then I'm going to get 1/2 du equals dx. And then I'm going to do my substitution. Now, what I like to do here is I also remember that these limits of integration, these guys are actually in terms of x. So I've got to change them to be in terms of u. So right here, what I'm going to do is I'm going to take and say, okay, well, this is x equals 1. So when x equals 1, if I plug that in right here, what do I get? That's 2 minus 1, which tells me that u is equal to 1. Okay, well, what about when x is 5? Well, when x is 5, I get 10 minus 1. That tells me u is equal to 9. Okay, so now I've got new limits. So I'm going to go ahead and make my substitution now. So my substitution is, I'm going to go from 1 to 9 now, because that's what I'm doing here for my u. And x was equal to 1/2 u plus 1/2 times, this is u to the negative 1/2, right? U to the negative 1/2. Okay. So then I could, and then I need my 1/2 du. 1/2 du. So then I'm going to go ahead and multiply this guy inside, and the 1/2, sure, I could do the 1/2 inside too. So 1 to 9 of 1/4 u to the 1/2 plus 1/4 u to the negative 1/2. Okay, okie dokie. So let me do my antiderivative, and I'm going to get, let's see, 3/2. So 1/4 u to the 3/2 over 3/2 plus 1/4 u to the 1/2 over 1/2, and I'm going to evaluate that from 1 to 9 this time. So let's go ahead and plug in 9 in there, and let's see what happens. Let's see, this 2 is going to cancel out with this 2. It's going to be 1/6. So I'm going to have 1/6 9 to the 3/2 plus 1/2 9 to the 1/2 minus 1/6 1 to the 3/2 plus 1/2 1 to the 1/2. Okay, move this guy up a little bit here so we can see what we're doing. And again, this is an answer, so we can go ahead and you know, the answer because we plugged it all in. But if we needed to do all the math out, we can do all the math out. Remember that the 9 to the 3/2, that would be 3 cubed, right? So we can do all this work, and we're going to end up with 16/3 if we really want to do all that work out, okay? So that is, these are, oh, I got one more here, number 13. So again, fundamental theorem of calculus. This is a reverse chain rule, so I need a hook on here. So I need 2 right here and 1/2 right there so that I can hook that on there, right? Okay, so then the antiderivative cosine is negative sine 2x evaluated from 0 to pi over 2. Oops, I don't want to forget my 1/2. 1/2. Okay, so then I'm going to get negative 1/2 sine of pi over 2 minus negative 1/2 sine of 0. Okay, I could leave that like this, or I can simplify it. Sine of pi over 2. So sine of pi over 2 is up on the top there. Sine of pi over 2 is going to be 1, so negative 1/2. Sine of 0 is 0, so I'm going to end up with negative 1/2. Okay. All right, so that's the fundamental theorem of calculus, guys. All you got to do is do the antiderivative and then plug in your values. The top one first minus the second one. All right, then you've got the fundamental theorem of calculus. Catch you later for the next video, which is on spam.